Yeah, so last time we talked about measures of central tendency, representative values for a set of data. Okay, well, that describes data a little bit, but take a look at these two distributions here. Let's say A is 5, 6, 7, 8, 9, and then B is 1, 2, 7, and 12, and 13. Okay? So our measures of central tendency, the mean, X bar we called it, what would be the mean here? If I add those up, so that means the average. So if I average these, 5 plus 6 plus 7, what's that, 18 plus 17, yeah, that's 35. Divide that by 5 and you got a mean of 7. So also notice here, the median, what's the median here? This one.
7.
Also 7, yeah, the median is just the middle one. And you look at the middle one's just 7, okay? Now, B, when you say it's quite a bit different than A. I mean, it's got 5 values, but the values themselves are kind of different. They're more spread out for one thing, you know what I'm saying? However, what is the mean here? If you add these up, 10 plus 25 is 35, divide by the 5, you got 7. What's the median? Also 7. Okay, so you see, those don't really tell you a lot about dispersion. That's what we're going to talk about here today. A's are not as dispersed as B's. Dispersed meaning more spread out, right? And so the measures of dispersion, there's a couple of them. One is very simple and it's probably not as used as the other one. It's a little more complicated, but it's used more. One measure of dispersion is just simply the range. How much, basically the range is just the largest value minus the smallest. Easiest way to put it. And so that does, gives us a little hint as to one of the differences here. What's the range of A? Well, the range of A would be the largest value is 9 minus the smallest value is 5. So the range is 4 there. And then the range of B would be 13 minus 1, so that's 12. So it does have a bigger range. All right. So that does give us a slight hint into, yeah, these are more spread out. But because of the fact, for one thing, that this calculation only uses the smallest and the largest value, doesn't say anything about the ones in between, it's limited in its use, so just be aware of that. No, the other measure of dispersion that we'll talk about it's called the standard deviation, and it's more widespread used measure of dispersion. So it also measures dispersion, standard deviation. Now, what we might first want to talk about, though, before we talk about the standard deviation, is what we mean by deviation. Deviation, that term just means deviation from the mean. So it's how much a value in one of your values deviates from the mean. For example, let's just do A here again. A is 5. Write the values this way though. 5, 6, 7, 8, and 9 are the values for A. All right, so deviation from the mean. So let's start, let's just list all the deviations on this second line here. Okay, so deviations mean deviations mean. So the way I calculate is I take, let's just call one of the values X. I take the x, whatever the value is, and just subtract the mean. That's how you get, if you want a formula, that's the formula. You take the value minus the mean. So one way you could write is x minus x bar. Or you could just say value minus mean. Okay, that's what that means. All right, so let's start at 9. So I take 9 and minus the mean. What's the mean over here? 7. So the deviation for 9 would be 9 minus 7. So the deviation is 2. All right, so it's pretty easy computation. Deviation for 8, so you take 8 minus the mean, so 8 minus 7, that's 1. 7 minus 7, well, that's going to be 0, because it is the mean. Deviation 0. Now what happens on 5 and 6? Well, 5 and 6, 6 minus 7, you got a negative, right? Negative 1. And 5 minus 7, because you're taking the value minus the mean. The mean's bigger, so you're going to get a negative value for those deviations there. Right? Okay. Now, what standard deviation then, what we try to do with it is we try to get like an average of these deviations. The problem though is, if I average the deviations, add all the deviations up, and then divide by the number there are, notice if I add these deviations up, what happens? Negative 2 plus negative 1. If I add those all up, what happens? You get 0, okay? And that's typically what happens when you add the deviations up. You get 0. And so that's not going to help us if every time we do the deviations and average them, we get 0. That doesn't help us at all. So here's what we do. So to get rid of the negatives here, here's what we're going to do. The next line here I'm going to put are the square deviations. So I'm just going to take each deviation and square it. So this next one here, under this one, would be negative 2 squared. Well, negative 2 times negative 2 gets a positive 4. So that gets rid of the negatives, more or less what that does. Negative 1 squared is positive 1. 0 squared, of course that's still 0. 1 squared is 1, and 2 squared is 4. All right. So now, when we add those up, we don't get 0, right? All right, so here's our, so that's kind of the preliminary work, one way to write it anyway. Here's how we get the standard deviation. What I'm going to do is basically average these values. Well, let me first of all, standard deviation, X bar is mean, S is the letter for our standard deviation, what we usually call it. All right, so here's how I'm going to calculate this standard deviation. I'm going to add up all of the squared standard deviation. So the top line here is the sum of the standard deviation, squared standard deviation, squared deviations. Say it right here in a second. Top line is the sum of the squared deviations. All right. Then, turns out, I'm not going to divide by the number there are. I'm actually, for this S, I divide by n minus 1. Now, remember what n is? Just the number of values there are. But to do the standard deviation like this, we need to subtract 1 from it. All right? And then, okay, so I'm not wanting an average square deviation. I want the just standard deviation or average sort of deviation. These are square deviations, so I need to square root that. So it's kind of a complicated, more complicated formula, but not that bad. So in our example here, so the top line here, I'm just going to add the 4 plus 1 plus 0 plus 1 plus 4. Just add those all up right there. Then I'm going to divide, I've got 5 of them, so I'm going to divide by 5 minus 1, and then square root all of that. So what does that give me? 10 divided by 4, which is 2.5. But then I square root that, and that gives me 1.58. And so the standard deviation of A is going to be 1.58. Okay? So it, like I said, this is what this is kind of an average deviation. How much each value is deviating from the mean, average-wise, okay? So this is a sort of average of how values deviate from the mean. So on average, they're deviating from the mean 1.58 units, okay? All right. Now, let's do for B. Now, what would you expect on it? A higher or lower standard deviation?
Higher.
Higher, yeah. They're deviating more from the mean here, aren't they? They're deviating more because they're more spread out. So we would expect B to have a standard deviation higher. So let's calculate our little standard deviation of B. So B, I've got 1, 2, 7, 12, and 13. All right, so first step is do the deviations, which is just the value minus the mean. Well, the mean on B is the same as A in this case, so the mean is 7. So again, I'm just subtracting 7 from each of these to get these deviations. So I've got -6, 2 minus 7 is -5, 7 minus 7, so 0, 12 minus 7, 5, and 13 minus 7 is 6. Okay? Step 2 then is square the deviations. So squaring each one of these, well, you're squaring positives and negatives, but you're squaring, so you're going to get positives in all cases here. -6 squared is 36, -5 squared is 25, 0 squared is 0, 5 squared, and 6 squared is 36. And so now we're able to compute this standard deviation called S. All right, and so this one, the top line, we just add the square deviations up. Don't have to necessarily write them out, but I'm just showing you what I'm doing here. And then divide by n minus 1. Well, again, I've got 5 values, so it's going to be 4 for the denominator there. So it's square root, this obviously is a larger number. 122 is the top, is that right? Divide by 4. So you got the square root of 30, 30.5? Which is, yeah, that's a bigger number. I don't remember what it is. It's big enough. 5.52. So the standard deviation of B is a 5.52, which again speaks to the fact that these are more dispersed. So the larger the standard deviation, the more dispersed the values are. That's what the intent of that calculation is. The larger the standard deviation, the more dispersed the values are. We verified that with one of this example. Okay, so that's what this deviation, standard deviation describes dispersion. Smaller standard deviation means less dispersion. Larger standard deviation equals more dispersion. Okay? Keep that in mind. All right, so let's do just do another one here and then have another question or two. Any thoughts or concerns there?